Hello and welcome to yet another video of Cornerstones of Math. In this video, I will solve a problem that looks like a simple equation but actually has deeper meaning. The equation looks simple. We have to find the real number solution of square root of x plus 3 equals square root of x plus 1 plus square root of 2. The method here is pretty straightforward. We square both sides to remove sum of radicals, considering this 1 plus square root of 2 as a single variable. This gives x plus 3 equals x plus 2, 1 plus square root of 2 square root of x plus 1 plus square root of 2 squared. Notice that x gets cancelled out, so we have 3 equals 2, 1 plus square root of 2 square root of x, and if we expand the square part, we can easily obtain 3 plus 2 square root of 2. So now 3 get cancelled out. So moving this term, we have minus 2 square root of 2 equals 2, 1 plus square root of 2 square root of x, which gives square root of x equals minus square root of 2 divided by 1 plus square root of 2. So if we square both sides again, we can obtain x, which is 2 divided by 3 plus 2 square root of 2. And if we rationalize the denominator, notice that the denominator becomes 9 minus 8, which is 1. So we only have 2 times 3 minus 2 square root of 2. So this seems like the real root, but we have to check. So let's calculate the left-hand side and the right-hand side of the equation. For the left-hand side, which is square root of x plus 3, we have square root of 2, 3 minus 2 square root of 2 plus 3. So square root of 9 minus 4 square root of 2. Here, let us use the following denesting formula to remove the nested radical. If the inner part can be expressed as the sum a plus b minus twice the square root of the product ab, then this inner part is square root of a minus square root of b squared, so it can be written as square root of a minus square root of b. In order to apply this formula, we have to have 2 here. So let us change this 4 square root of 2 into 2 square root of 8. So we have to find two numbers whose sum is 9 and product is 8. And it is not difficult to find that 9 is 8 plus 1 and 8 is 8 times 1. So we have square root of 8 minus square root of 1 squared. So we have square root of 8 minus square root of 1, which is 2 square root of 2 minus 1. This is the left-hand side. And now let's compute the right-hand side, which is square root of x plus 1 plus square root of 2. So we have square root of 2, 3 minus 2 square root of 2 plus 1 plus square root of 2. So square root of 6 minus 4 square root of 2 plus 1 plus square root of 2. So again, we change 4 square root of 2 into 2 square root of 8. Now the sum is 6 and the product is 8. These two numbers are 4 and 2. So 8 equals 4 times 2. So we have square root of 4 minus square root of 2 plus 1 plus square root of 2, which simply equals 3. So the left-hand side is 2 square root of 2 minus 1, and the right-hand side equals 3. So the left-hand side is not equal to the right-hand side. In fact, the process I've shown here is even invalid in this step, when we obtained square root of x equals minus square root of 2 divided by 1 plus square root of 2. Notice that left-hand side is positive or equal to 0, and the right-hand side is negative. Hence, there's no way that this equation is satisfied. Therefore, the obtained root x equals 2 times 3 minus 2 square root of 2 is an extraneous root, so we have no real number solution. You can even check this by graphical method. Here, red and blue curves are graphs of y equals square root of x plus 3 and y equals square root of x plus 1 plus square root of 2, which are basic radical functions whose graphs are easily understood. This green line indicates the root that we have obtained, x equals 2 times 3 minus 2 square root of 2. Notice that two curves never intersect, nor they ever cross the green line at the same point. This means that x equals 2 times 3 minus 2 square root of 2 is indeed an extraneous root, and our given equation has no real solution. But this raises another question. Why? And what is the origin of this extraneous root? Well, since we are currently dealing with graphs right now, I will provide the graphical insight first. Notice that if we draw this flipped graph, which is y equals minus square root of x minus 1 plus square root of 2, then you can see that two curves meet at x equals 2 times 3 minus 2 square root of 2. This means that our extraneous root x equals 2 times 3 minus 2 square root of 2 is the real root of the equation square root of x plus 3 equals minus square root of x plus 1 plus square root of 2. In fact, if we compare the left-hand side and the right-hand side of the equation, the left-hand side is unchanged, so it is still 2 square root of 2 minus 1, and on the right-hand side, we have obtained this for the original equation, and the difference with minus sign here is that this part changes to minus, so we have 2 square root of 2 minus 1. Therefore, the left-hand side is indeed equal to the right-hand side, meaning that this value is the valid root for this equation. In order to gain more algebraic insights, let's compare the processes of solving two equations. First, we square. The only difference is that now we have minus sign here. Then we cancel x, so we have these, and we cancel 3, which gives these. So square root of x equals these, and by squaring again, we arrive at the same root. And you can easily notice why we arrive at the same root. It's because a squared is equal to minus a squared, even if a is not equal to minus a. So this value satisfies the right equation, but not the left one. So the moral of this video is, when solving radical equations, always check whether the obtained solution is valid. And that's all for today's video. Thank you for watching, and I will see you in another video.